So the learning objective of the class today we'll discuss about the macromolecules. The term macromolecules refers to giant covalent structure or giant molecules refers to macromolecules. So in this session you should be able to describe the giant covalent structure of a graphite and diamond. You should be able to describe the macromolecular structure of silicon 4 oxide or also known as silicon dioxide. We also call that as sand, and then relate their structure to their uses. Like graphite can be used as a lubricant, so relate why it can be used as a lubricant or why it can be used as a conductor or conduct electricity, and diamond can be used for cutting tools. And then describe the similarities in property between diamond and silicon 4 oxide related to their structure. So this will be our learning objective for the class today. So first thing, when we have a covalent substance, so what is a covalent substance? Covalent substance is just formed by sharing of electrons. So when the electrons are shared between the two atoms, they will form a covalent substance. And you have to keep this table in mind that if the element, because it's about the non-metal, so only for 4 groups, if it is group 4 non-metal, it will share 4 electrons. All the 4 electrons will be shared, and unshared will be 0. There will be no unshared electron from group 4. If it is group 5, it will share 3 electrons, and unshared will be, because group 5 means there are total 5 electrons in the last shell. Out of 5 it shared 3, so how many unshared will be there? The unshared will be 2. If it is group 6, it will share 2 electrons, and how many unshared will be there? Because it is group 6, so it means it is having 6 electrons in the outermost shell. So out of 6 it shared 2. Unshared which are left will be 4. And group 7, the group 7 element will share 1 electron, and out of 7, if it shared 1, how many unshared are there? Unshared will be 6. So this is always fixed depending on the type of the element, which group it belongs to. So this table is very important when we are drawing the structure of covalent substance. Then these covalent substances are divided into 2 categories. One is known as the simple covalent or molecular covalent, and the other one is known as the giant covalent, or known as macromolecular covalent. So what is the difference between both? Have the covalent bond, both have the sharing of electron, but what will be the difference in their structure? So in a simple covalent or a molecular covalent substance, there are finite atoms. Finite means fixed number of atoms are there in the structure. Whereas for a giant or a macromolecular, So for a giant or a macromolecular, what they have infinite or uncountable atoms in the structure. And there can be many substances which can have infinite number of atoms in the structure or uncountable atoms in the structure. So how we can work out or how we can identify, we don't have to learn all the macromolecules, we just have to learn or recall the three examples. One is diamond, graphite, and sand. So these are the three structures which you have to learn the macromolecular structure. There are more macromolecular structure, but that you don't have to learn. So example, if I draw a structure, I write H, O, and H. What kind of structure is this? Simple or macro? Macro means giant. What kind of structure is this? A simple covalent or a macromolecular? So because you can clearly see the number of the atoms here, there are finite number of atoms, there are fixed number of atoms, 2 hydrogen and 1 oxygen. So what we say, this will be simple. But if I draw another structure, and the dotted lines are there, what is the meaning of this dotted line? The meaning of this dotted line means that the structure continue, like it's going on, lot of atoms are there. So what kind of structure is this? Is it a simple or a macro? So it is a giant structure, or we also say it is a giant macromolecular structure. Is it clear that how you can distinguish between a simple and a macromolecule? So in a macromolecule, it will be infinite number of atoms, whereas in a giant, in a simple one, it will be a finite number of atoms. Another example, what is the structure? Is it a simple or a macro? What kind of structure is this? So because the dotted lines are there, so what these dotted lines are representing, these dotted lines are representing that the structure continue. There are a lot of atoms which are attached to this. That's why it is a macromolecular structure. So the three macromolecular structure which you have to learn about diamond, the structure of a diamond. So what is the structure of a diamond? Basically, diamond consists of the carbon atoms. The carbon atoms are there, but it is a macromolecular. So what kind of structure is this? You have one carbon which is formed because carbon belongs to group 4, so it is forming 4 bonds. So this carbon form 4 bonds, then there will be another carbon that will form 4 bonds. There will be another carbon that will form 4 bonds, and the structure continue. So this is the structure of diamond, in which each carbon is forming 4 bonds with another carbon and the structure continue. What does it mean, like structure continue? Like if I draw or try to complete the structure, I have to show a dotted line. So it will be, this will have 3 carbon, then one is already there, 1 2 3, then one is already there, 1 2 3, and then this carbon will also have 4 bonds, this carbon will also have 4 bonds. So it is a very big structure, it is a giant structure. We don't have to draw full structure, as it is, we don't know the number of the carbon atom. So in exam, if they say draw the structure of diamond, so what you will do, so how you will draw the structure of diamond, you will draw one carbon, then it is attached or form 4 bonds, and thus show the dotted line for the remaining carbons, which shows or which means that the structure continue. Is it clear? The structure of the diamond. So basically in a diamond, what happened, the carbon, as it belongs to group 4, so it can form 4 bonds. So this is one carbon which can form 4 bond with other carbon atoms. So 1 2 3 and 4. Then this carbon can also form 4 bond, one is already there, then remaining 3. The second carbon can also form 4 bond, the third carbon can also form 4 bond. So means this structure will continue. It will be a giant structure, but we don't have to draw the full structure. That's why we just represent, and at the last we just draw and make dotted lines. Then the structure of graphite. And this name, there's a name for this structure. What we call this type of structure, because it is having 4 ends, so we call that as tetra. The term tetra means 4, and it is hedral. So it is a tetrahedral structure. This is a name geometry. According to the geometry, this name is given to the structure, that the diamond is having a tetrahedral structure. These are the things which you have to memorize, because in chemistry there are, like, understanding is there, but you have to memorize certain things. So in case of diamond, you have to practice the structure as well as learn this term, that it is having a tetrahedral structure. And the term tetra, it's easy to remember. The term tetra means 4. So you can see this is forming a 4 bond. That's why it is called a tetrahedral. The second structure which you have to learn, that is the graphite. So what is the structure of a graphite? You have to make a hexagonal ring. The term hexa means 6. So we have to make a ring of 6 carbon atoms. So this is 1, 2, 3, 4, 5, 6. As you can see, 6 carbon atoms are there in a ring. This is called hexagonal ring. Same thing, because it's a giant structure, so it continues. So this is one carbon, 1, 2, 3, 4, 5, and 6. So these rings are connected with each other. Same way, if we continue, if this is 1, 2, 3, 4, 5, and 6. So this is another ring. So When these rings are connected with each other, what we call that as a layer. So this is one layer or layer 1 of graphite. And like this, graphite is having a layer structure, a hexagonal ring, and a layer structure. So this is one layer of a graphite, and this structure will continue, but we are not drawing full because it will continue like this. Then we draw the second layer. How to draw a second layer? So same way, 1, 2, 3, 4, 5, 6. So these 6 carbon atoms are there in a ring, we call hexagonal. Then we take any one of the carbon you take from the ring and start with that one. So 1, 2, 3, 4, 5, and 6. And same thing, if we take 2 carbon, 1, 2, 3, 4, 5, and 6. So each ring is having a 6 carbon atoms, and this is the second layer, or we also can say layer 2. And like this, the graphite will have layers. Like there will be layer 1, there will be layer 1, then layer 2, layer 3, layer 4, and so on, because it is a macromolecular structure. Is it clear? The concept of the graphite structure, that it is a hexagonal ring which is having a layer structure. So it is you have to understand the structure as well as you have to practice, because in exam, no, not 3 structure in the layer, Abdullah. It can have many structures in the layer. I just drew 3, but actually it will continue. So example, as a hexagonal ring, 1, 2, 3, 4, 5, and 6, and then just take 2 of them. So 1, 2, 3, 4, 5, and 6, and then 1, 2, 3, 4, 5, and 6, and this will continue 1, 2, 3, 4, 5, and 6. There will be many rings in one layer, but we are not drawing all of them. So this is layer 1, and there will be 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, like 1, 2, 3, 4, 5, and 6. So like this, each ring will have 6 carbon atoms. In exam, you just have to draw 2 of them. You have to draw 2 layers, at least 2 layers, and 2 rings in exam. And it can have infinite number of atoms. So a layer can have infinite number of atoms, but the ring will be hexagonal. Hexagonal means that each ring will have 6 carbon atoms. Is it clear? The structure of a graphite. So if the question is there in exam, they ask to draw the structure of a graphite. So how you will draw? 1, 2, 3, 4, 5, 6. That is 1. Then 1, 2, 3, 4, 5, 6. And same way, we'll draw at the bottom 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, and 6. So this is according to the exam what you will draw in exam. You can just show a dotted line that shows that the structure continues. Is it clear? The structure of a graphite? Yeah, layers, we don't have to connect the layers because it's a layer structure. The layer 1 should not connect with layer 2. Layer 1 is different from layer 2. So you should not connect them together. If you connect them together, then you will lose the mark. So the two layers should be separated from each other. Is it clear to everyone? Then the last one is a structure of a sand, which is also known as silicon 4 oxide. This is a name, chemical name of a sand. It's also called silicon 4 oxide, or it is also called silicon dioxide. So what is the structure of a sand? Silicon 4 oxide or silicon dioxide? So it contains silicon. It contains silicon. Silicon belongs to group 4. So how many electrons will be there? It will share the number of electrons. The silicon share. It belongs to group 4. So it will share 4 electrons. And how many unshared will be there? Because it does not have any, all 4 are used in the sharing. So there is no unshared electron. And what about oxygen? Oxygen belongs to group 6. So as it belongs to group 6, it will share 2 electrons and unshared will be 4. Now what is the structure of silicon 4 oxide? So how we draw the structure of silicon 4 oxide? Like this is one silicon surrounded by 4 oxygen. 1, 2, 3, 4. Because the formula is SiO4 for silicon 4 oxide. So what happened? When oxygen share 1, silicon will also share 1. Oxygen share 1, silicon will also share 1. Oxygen share 1, silicon will also share 1 from that side. Oxygen shares 1, silicon will also share 1 from that side. But now what happened to another oxygen is left with another electron to share. So that oxygen will share with another silicon. So this oxygen share 1, silicon will share 1 from that side. Oxygen share 1, silicon will share 1 from that side. And oxygen share 1, silicon will share 1 from that side. And same way this structure will continue because this oxygen is connected with another silicon. So it will form a bond with oxygen, it will form a bond with oxygen, it will also form a bond with oxygen. Then there will be another silicon which will form a bond with oxygen. So there are a lot of silicon and there are a lot of silicon and oxygen atoms in the structure. When there are a lot of silicon and oxygen atoms in the structure, what we call this structure? We call that as a macromolecule. But in exam, we don't have to draw this structure because it will be too much complicated. So exam point of view, if you want to draw a structure of silicon 4 oxide, so what you do, you will draw one silicon and show 4 oxygen around it and then put the dotted line. So when you are showing a dotted line, what does it mean? It means that the structure will continue. And how it will continue? You have one silicon forming a bond with oxygen. Then another silicon forming a bond with oxygen. Another silicon forming a bond with oxygen. And it will continue. So this is the actual structure of silicon 4 oxide. The structure, if they ask to draw an exam, so this should be your structure which you will draw an exam. So this is a structure of silicon 4 oxide, also known as sand. And why some elements can form giant structure and some element can form simple? If element can share greater number of electrons, so they have the tendency to form a giant structure. That's why you can see silicon which can share 4 electron or carbon which can share 4 electron. Both of them can form a giant structure because they can share maximum number of electrons. So as the element, mostly group 4 element, as they have a tendency to share 4 electrons, so they some of their compounds are a long chain compound or a giant or macromolecular structure. So now we'll compare the structures of silicon. This is the main idea about the macromolecule. Now we'll compare the structure of silicon, diamond and graphite. So the objective, describe the giant structure of a graphite, diamond, and describe the macromolecular structure of silicon 4 oxide. So this is a structure of a diamond. You can see it will continue, but in exam, you don't have to draw this hole. What you will do in exam, so if they ask draw the structure of the diamond, then you should only draw till this point. That's it. Same way, if they ask draw the structure of a graphite, so what you will do, you don't have to draw the full structure. You just 2 layers are enough. To show the structure of graphite. And if they ask draw the structure of silicon 4 oxide or silica or silicon dioxide or sand, so what should be your structure? So this will be the structure which you will draw. Not all of the layers are connected, Abdullah. That's why you don't have to show a connection. Few layers are connected, not all of them. So you don't have to show the connection between the layers. You can just draw a dotted line. Between the layers, you can just draw a dotted line. That's it. That's enough. So if they ask, explain the bonding, what happened in diamonds? So what happened in diamond, each carbon atom has 4 covalent bond with other carbon atom. So this gray shade is representing a carbon atom. So you can see this carbon atom is forming a bond with 4 carbon atoms. And how the carbon atoms are arrangement, how they are arranged. So carbon atoms are linked together to form a giant structure or a macromolecular structure. When you check graphite, each carbon atom has a 3 covalent bond. You can see if I pick any one of the carbon atom, it is having 3 covalent bond, 1, 2 and 3 with other carbon atoms, and van der Waals force hold the layer together. Actually, this line is representing a van der Waals force, the force between the layer, force between the molecule, having a specific name. It is named after a chemist. So that is also known as van der Waals force. So the van der Waals force refers to force between the particles or molecules. So there is a weak force between the layers. And when we check the arrangement, arrange in a hexagon. Hexa means 6. So it is arranged in a hexagon and arranged in a layer on the top of each other. An electron can move through the layer. So if electron is here, this electron can move from one layer to another. How diamond is having a 4 bond? Because diamond consists of a carbon, so carbon belongs to group 4. That is why here the diamond, the carbon is forming a 4 bond. But in case of graphite, carbon should form 4 bond, but it is not able to form a 4 bond because of hexagonal ring. So it is only forming 3 bond, and one of the electron is free, which can move from one layer to another. And for silicon 4 oxide or sand, each silicon atom is bonded with oxygen, 4 oxygen atoms. So you have one silicon and you have 4 oxygen. And atoms are linked together by a giant structure. So there's a giant structure by which these all atoms are linked together. Is it clear? The 3 points: first the structure, bonding and arrangement. Any question till now? You can use the chat or you can use your mic to ask your doubts or a question. Yeah, that's right. The diamond and the sand having a same structure, but the only difference that diamond consists of all the carbon atoms, where sand consists of silicon and oxygen atoms. That's a difference. So we discussed structure. You should be able to draw the structure. You should, if they ask, explain the bonding. So what should be your answer? In diamond, each carbon have 4 covalent bond, whereas graphite, each carbon having a 3 covalent bond, and in silicon 4 oxide, each silicon form 4 covalent bond with oxygen atom. And how they are arranged? Their carbon atoms are linked together to form a giant structure. Hexagons are there, rings are there, and one layer is over the other layer. And in silicon 4 oxide or sand, it's also a giant structure which is linked together by a covalent bonding. Then the properties, what are the properties? It does not conduct electricity. These are the properties of the diamond. It is having a high melting point and it does not dissolve in water. So these are the 3 properties of a diamond: does not conduct electricity, high melting point, and insoluble. Why it does not conduct electricity, the diamond? Because there is no free electron or ions. So if there are no free electrons or ions, that's why it cannot conduct electricity. Why it is having a high melting point? Whenever the structure is a giant, it will have a high melting point. You need lot of energy to separate these atoms from each other. So it will have a high melting point. And insoluble in water. So insoluble in water because the covalent substances are there and covalent substance does not dissolve in water. When we check the properties of a graphite, it can conduct electricity. So why a graphite can conduct electricity? As you can see, if this carbon is forming 3 bonds, 1, 2 and 3. So there is one electron available and this electron can move from one layer to another. So this electron is free to move. There is a free electron in the structure. That's why it can conduct electricity. Then it is having a high melting point. Why it is having a high melting point? Whenever there is a giant structure, it will have a high melting point. And insoluble in water. Why it does not dissolve in water? Because the covalent substances are insoluble in water, does not dissolve in water. When we check silicon 4 oxide, so silicon 4 oxide, when we draw the structure, there is no free electron for silicon or oxygen. That's why it cannot conduct electricity. So there is no free electron. Why it is having a high melting point? Because it is having a giant structure, so high melting point. And why it is insoluble in water? Because it is a covalent structure and covalent structure are insoluble in water or does not dissolve in water. How the diamond looks or appear? It is the hardest substance known. It is a colorless crystal which sparkle in light. How graphite appear? Graphite appear as a dark gray, shiny solid with a slippery feeling when you touch. Like example, when you check the pencil needle, you will find that it is soft and slippery. Why it is soft and slippery? because your pencil needle is a combination of graphite and clay. So because of the presence of the graphite, it appeared to be dark gray in color, and it is soft and slippery due to why it is hard, transparent and colorless. So what is the reason why the diamond is hard, transparent and colorless? You can see that these carbon atoms does not have too much space to move. That's why it is hard. Why it is transparent? Because they allow the light to pass through. But for a graphite, because it's a layer structure, so the layer structure does not allow the light to pass through. And why it is slippery? Because these layers are there. A graphite is having a layer structure, and these layers can slide over each other or slip over each other. That is why the graphite is slippery in feeling. And for silicon 4 oxide, it is also hard, it is colorless, because you can see it is having a same structure as diamond. Then the uses are there. Diamond is used in jewelries, graphite for lubricant, and silicon 4 oxide for cement. Is it clear, this table? Any question or a doubt related to this whole table? So it is very important for exam point of view that you should be able to relate the structure with the properties and the uses of each. So why we use diamond for cutting the substance? Because it is a hard substance. Why we use graphite for lubricant? To reduce the friction, because it is soft and slippery. And why we use silicon 4 oxide for in a cement? Because it can bind the structure, it can join the structure, so it is used in cement. So we'll continue this discussion of macromolecules. I'll share another link and we will do some questions related to the topic. Any question or a doubt till now? So I will end the session and share another link. Is there any question or a doubt? So it is very important table and you have to actually memorize, learn, so that you will not lose any marks for the questions related to diamond, graphite or silicon 4 oxide.